Hello, welcome to our college, Praveen Patel College of Diploma Engineering and Technology. Our department is Humanity and Science. Course obviously Basic Mathematics course code 22103. Again, myself, Mrs. Smita Shekhar Kamble. Today's lecture most concerned with our very favorite chapter. Yes, matrices. Unit is 1 and chapter number is 3. Unit 1 is totally depend on algebra. Means algebra totally depend on addition, subtraction, multiplication and division. That's why we have to focus about the matrices chapter. Very basic topic, that is adjoint of a matrix with example. Last lectures we have to take the addition of the matrices of any order, subtraction of matrices of any order. Order means rows and columns. Two rows, two columns. Two rows, three columns. Three rows, two columns. Three rows and three columns. So multiplication also we have to take there. We have to multiply the two rows and two columns, that is 2 by 2 order matrix with different matrix, that is B. Or we have to take the same matrix multiplication with same matrix. The matrix multiplication is over. For division, the direct division is not possible in matrices because we have to consult with the different matrix. Suppose 4 is divisible by 2. It is linear, but it is not possible in a matrices. So that's why we need the basic concept adjoint of a matrix. Now we have to start our topic. Adjoint of a matrix. To find adjoint of a 2 by 2 matrix, step 1. A is equal to A11, A12, A21, A22. The two rows and two columns are there. Obviously, how many rows we have to take? Two rows and two columns. Yes, right. First row is A11, A12. Second row A21, A22. First column A11, A21. Second column A12, A22. We have to find the adjoint of A. Very easy trick. We have to interchange A22 with A11 and A11 with A22. Then we have to change the sign of these elements only. That is, A12 remains same, but sign will be changed. If it is positive, become negative. If it is negative, become positive. Here, A21 also we have to change the sign. If it is positive, get negative. If negative, get positive. That is the compulsory step we have to follow. That's why adjoint of A is normally given by 2 by 2 order matrix is we have to interchange A11 with A22, A22 with A11 and minus A12 and minus A21. We take the example based on the adjoint of matrix. Example is given 6, 5, 2, 1. Our adjoint of A is defined by interchange 1. Instead of 6 we have to write 1. Instead of 1 we have to write 6. We have to interchange. The sign will be changed of the A12, that is minus 5, and the sign will be changed of A21, that is minus 2. So I given the example to practice. You have to must note down. If you want to remind the A11, A12, A21 and A22, the simple alphabets also you have to use. If ABCD is the matrix, then adjoint is defined by D minus B minus C A. So these also trick you have to remind. Okay. Now it focus about the example. Adjoint of A is equal to 3, 2, 1, 4 is given. We have a shortcut method to find adjoint of a 2 by 2 matrix, that is interchange the signs. That means we have to interchange the element and change the sign. How it is possible? It is look like in a diagram. Adjoint of A. Suppose this is the example. So blue color is the changing of the elements and this pink color indicate change of sign. So it is easy now. So we have to change, instead of 3 we have to write 4, instead of 4 we have to write 3, instead of 2 we have to write -2, and instead of 1 we have to write -1. So we know that it is the shortcut method to find adjoint of A. Now next example, find adjoint of A, 2, 3, 1, 4. So same method we have to follow. We have to interchange 2 and 4 and we have to change the sign of 3 and 1. So it is, we have to change, instead of 2 we write 4, instead of 4 we have to write 2, and sign +3 is there, so it is -3, +1 is there is -1. Suppose A is given. So what is the, A is given -3, 4, 6 and 2. So what is the trick? We have to interchange 2 and -3. Yes, right. We interchange, instead of -3 we have to write 2. Instead of 2 we have to write -3. So I write here. Instead of 4 we have to write -4. And instead of 6 we have to write -6. The cofactor method is also applicable to solving. It is same trick. I derive the same steps and we derive the shortcut method. 1, 2, 3, 4 is the A11, A12, A21, A22. So A11 is equal to -1 raised to 2 and 1, 1 plus, that is first row, first column, A22. So -1, it is the, we have to take the 4. So we have to take the A22, A21, A12, A11. That means we have to check A11 cofactor is given by -1 raised to, here 1 plus 1 and element is A22. So -1 ka square, that is +1, that's why 4 remain as the same. A12 is -1 raised to 1 plus 2, A21. That means what? -1 raised to 3 into 3. A21 is what? Comparing these 3. So that's why we derive the -3. So -3 why derive? Because the negative number cube is negative. That's why -3 derived. Next A21, -1 raised to 2 plus 1. So A raised to A12. Barabar? Then -1 raised to 3 and element is what? A12 is allotted here is 2. Barabar? Then it is -1 raised to 3. So -1 cube is -1. -1 into 2, -2. Now last A22. -1 raised to 2 plus 2. Because 2 is there, so 2 plus 2. A11 interchanging na. That's why -1 raised to 4 is +1. 1 remain as the same. So it is easy solving this way. Directly you can write the answer. We have to interchange, instead of 1 we have to write 4. Instead of 4 we have to write 1. Sign will be changed. Instead of 2, -2. Instead of 3, -3. So I derive 4 -2 -3 1. It is the procedure to explain the adjoint of matrix by stepwise. Now we have to discuss direct step. We have to apply. It is more suitable. So I revise the thing again. Our adjoint of A is equal to A11, A12 interchange and A12, A21 change the sign. That means what? A22 here, minus A12 is here, minus A21 is here, and here is A11. So I given the example for practice. Adjoint of matrices 2, 5, 7, 6 is there. Any guess what is the answer? Yes, the answer is 6. Here what? -5. Here -7 and here is 2. So we derive the answer. -1, 6, 7, 8. What is the interchanging of this? 8 goes to this side. So 8. Here is -1. Here is what? 6. No, it is minus 6. And here is minus 7. Now, we better understand by the adjoint of the matrices using this basic concept. So, most probably, I want to revise this thing because it is important. Adjoint of A, that is the shortcut method. We have to remind adjoint of A is equal to this diagram. We have to know A11, A12, A21, A22. That means these elements will be interchanged and we have to change the sign of these elements. Means what? Instead of A11 there is A22, instead of A22 there is A11, and we have to change the sign of minus A12 and minus A21. So in this way we have to more understand about the adjoint of A given by 2 by 2 order matrices. So you have to practice the more example by this way and solve it by using this method also. If ABCD is there, then what is our procedure? We have to, these diagonal element will be changed. Then instead of A we have to write D. Instead of D we have to write A. What is changed? Instead of B we have to write minus B. Instead of C we have to write what? Minus C. So we have to get more idea to develop the thing of adjoint of a matrix using the 2 by 2 method. In these examples, most thing is that here it is the criteria to solve by cofactor method. Most probably cofactor method is useful in 3 by 3 order matrices to find adjoint of such matrix. And today's lecture is totally depend on the adjoint of matrix of order 2 by 2. And so easy pattern is what? Switching the element leading to diagonal, change the sign of non-leading diagonal. That means adjoint of A is D minus B minus C A. So I given the example. Capital A is equal to minus 5, 3, 2 minus 6. What we have to do? We have to interchange these elements. Instead of minus 5 we have to write minus 6. Instead of minus 6 we have to write minus 5. Sign will be changed of 3. Instead of 3 we have to write minus 3. Instead of 2 we have to write minus 2. Same for B. 3 minus 2, 6, 4. Same procedure. D minus B minus C A. That means ABCD is there. We have to change what? D minus B minus C A. So instead of 3 we have to write 4. Instead of 4 we have to write 3. I write here 4 and 3. Now instead of, here minus 2 is already there. So minus minus become plus. That's why it is 2. And instead of positive number, that will be the 6. So from this method we have to most discuss about the determinant order. If the matrix have order A, B, C, D, which will be changed D minus B minus C, A. So we have to must practice the example, totally depend here. Always remind that interchange the diagonal and change the sign of these diagonal element. So you better practice the example I given to you. Note down the example. So our lecture is over.